Trigonometric integrals, part 1. Before we get going, I just want to run through formulas that I think you should either know or have real handy. And you should know that they exist so that you can look them up. And like I said, I would just keep them all very handy. And if you need it, if you're one of my students and you'd like a cheat sheet, just contact me and I'll send you one. All right, so we're going to start off with a very useful formula called a power reducing formula. It's also called the double angle formula, and it's used for cosine squared. We have another one for sine squared. Also, Pythagorean identities, those are very helpful as well. Your sine and cosine, and the one involving tangent and secant, and there's another third one involving cotangent and cosecant. So most people have the first one memorized. You might want to just memorize that the second two, that they exist and can be easily found. All right, how about your reciprocal identities? Well, remember that sine and cosecant are reciprocals, secant and cosine are reciprocals, and cotangent and tangent are reciprocals. Keeping those ideas in mind is also very useful. Knowing your basic derivatives. Derivative of sine, derivative of tangent, and the derivative of secant. Derivative of cosine, cotangent, cosecant. Once you have these basic derivatives memorized, they give you basic antiderivatives. For example, the antiderivative of sine and cosine. And then, if you have a coefficient in front of your variable, then you can use these formulas as well. And your antiderivative of secant and cosecant. And you just know them by knowing the derivative of that derivative of tangent is secant squared. So the antiderivative of secant squared would be tangent. And then I like to keep these formulas handy with the coefficient in front of the variable. Just makes it a little bit faster so that I don't have to do a substitution. These two formulas also come from just knowing derivatives. The derivative of secant is secant tangent, and the derivative of cosecant is cosecant cotangent. Now, this is a basic antiderivative, but it doesn't come automatically from knowing your derivatives. This one we had to derive after we learned about natural logarithms. And right now you just want to be able to keep that either memorized or keep it handy. The integral of tangent is log of secant. And then I have it written here with the case where you have a number in front of your variable. And cotangent, integral of cotangent is log of sine. The integral of secant and the integral of cosecant. I doubt you're going to memorize those, but you want to keep them handy. All right, so everything I've given you so far, those are things that you either just have to know or you have to know that they exist. Here's our first problem where we're going to use a strategy. This problem involves an even power of cosine, and using the power reducing formula is the best strategy for this problem. So using my power reducing formula and then pulling out the 1/2, I'm ready to integrate. The integral of cosine 2x, I just use my formula for integrating cosine of a number times x. And then I just distribute the 1/2. Let's do another example. Now here I have a product involving cosine and sine, and they're both to an even power. So again, I'm going to use power reducing formulas. There's a power reducing formula for cosine squared, and there's another power reducing formula for sine squared. Next, I'm going to multiply these two things together, and when the dust settles, this is what I get. Notice that I have cosine squared in my new integral. I'm going to have to use a power reducing formula again. And if you use a power reducing formula, you know, the angle, you have to go double what the angle is. So if it's cosine squared of 2x, then when you use the power reducing formula, the angle goes from being 2x to twice of that. And so you get the 4x. And then the rest is calculus 1 issues. First of all, you got to clean up inside the parentheses. And then after you do that, you're ready to integrate. And again, I used the formula for the antiderivative of cosine. And then you're ready to clean it up and you're done. So far, the two strategies we've looked at are strategies where we have an even power of cosine, or an even power of cosine and an even power of sine. In the next integral, we're going to look at some integrals that involve odd powers. Take care and have a great day.